Hello students, good morning to all. Welcome to your beautiful channel Firjan. Today we discuss electrostatic potential and capacitance. In this lesson, circuits with capacitor and resistor. When both capacitor and resistor connected in circuit, what are the situations we observe? Different situations. So means here when circuit contains capacitor and resistor, that cases we have two states is there. One is t equal to 0 time. This capacitor is act as short circuited capacitor. T equal to infinite time, capacitor is act as open circuit, that we can say steady state. In these cases, what are the resultant capacitance, resultant current, what is the potential changes, how changes, that we discuss today. See what concept circuits with resistor and capacitor. This is the concept today we discuss. See, myself is ready. It's your beautiful channel Firjan. See, circuits with a resistor and capacitor, this we call it as RC circuits. RC circuit. In this one we discuss first. See here, first we discuss here. See, capacitor, it is connected with resistor and battery here. See, battery connection, it is the circuit. See, it is capacitor, it is resistor, it is the cell. See here, battery means here minus, it is plus. See, current is flowing from here to here. See, in this case, see here, its potential is V, means here V, here 0. Why not it is 0? It is V. This is the RC circuit, means here capacitor is there, resistor is there, cell. So this we can say RC circuit, or we can write it as circuit with resistor and capacitor. What are the changes we observe? First one, see, for example, t equal to 0 time means initially t equal to 0. What about charge now? Here see, when battery is connected to resistor and capacitor, here potential maintains V. Here now charge is starting initially now, here charge equal to 0. What is the potential difference between the capacitor now, across capacitor now? See, 0 minus 0 means what here? See, we can write here charge equal to 0 for capacitor. For capacitor, what is the charge now? Here 0. So what is the change in potential now? Here see, change in potential is actually charge per capacitance. So charge is what here? 0. That's why 0 is the change in potential across capacitor. What is the change in potential across the capacitor now? 0. See, we can write current equal to what? V by R, means delta V by R. See, for example, here what is the charge? 0. It is the resistor. Here potential V. What is the change in potential across this one? V minus Q by C. What we can write? V minus 0. What we get here? I equal to, I write here, I equal to V by R, means maximum current it will passes. So means at t equal to 0 time means switch is closed. See, switch switch is closed immediately. So with time t equal to 0 time, what is the charge is 0 for capacitor. What is the change in potential across the capacitor na? 0. Why? Because charge is 0, 0 by capacitance. See, its capacitance is C, but charge is here 0. See here, for capacitor, change in potential across capacitor is 0. Why? Because charge is 0, 0 by something, 0 we get. See here, potential V here for resistor, here this end is what? 0. So means V minus 0, V. What is the current now? V by R means delta V by R. Delta V is what here? V minus 0. V we get, resistance is R. See, I equal to V by R means here current is maximum when t equal to 0 time, current is maximum. See next, the second case. See, I write here, it is the capacitor, it is the resistor. See, it is connected to cell. Here potential is V after time t equal to t time. T means since t equal to t time, after some time, what now here? After some time means t equal to t time. What now here? See, here electron taken and place here. So means here positive charge means deposited, means positive charge is here, electron taken here and place here, here minus, here positive, again we can take one more, here plus. So means here what, after some time some charge is here developed, so that charge here we can write small q, means here small plus q, here minus q. See, what is here potential? 0. What is the change in potential now here? See, charge is q equal to here, capital Q equal to q charge is deposited, means q charge is developed across the capacitor, here plus q, here minus q, here is q. Now see here, q equal to q for capacitor after time t. Yes, now what is the change in potential across capacitor? See here, it is charge is q, potential means q by c, here 0, q by c minus 0. See here, q by c minus 0 we can get, potential is across capacitor q by c. It is for capacitor. See, now we want to find out potential means current in the circuit, so that what we can write here? See, it is the resistor, here potential is V, here potential is q by c. Why not? Because of charge is developed on the capacitor, due to that what is the change in potential across the capacitor is q by c. We can write here what is the current now? V minus this V minus q by c, q by c by resistor, means here current is maximum, here somewhat decreases. Why? Because some charge means potential is developed across the capacitor, which it reduces the current. See here, I equal to V minus q by c, it somewhat decreases. See, first one here, capacitor, resistor, battery. Battery connected na, what happened here? Here electron means charge is taken, means electron is taken and placed here. So means what here? Plus q developed, here minus q developed. T equal to 0 time, no charge. That's why we can take here q equal to 0. That case initially t equal to 0, q equal to 0 for capacitor. What is the change in potential across the capacitor? Q by c. Q means what here? 0. So for capacitor, t equal to 0 time, what is the change in potential now? 0. So this here q by c equal to 0, here v across resistor, v minus 0, v means v by r, so I equal to v by r means maximum current. See, after time t means after t equal to 0 seconds, what happened now here? Here plus q, here minus q developed, time is changing, here plus q, here minus q, plus q minus q, plus q minus q, means why now? Here plus q means electron is taken and place here. So means here plus, here minus, again one more electron, here one more electron taken and place here, means here plus q, here minus q develops. See, because of charge developing in the capacitor, what happened? Some potential is developed here. What is that potential now? Q by c. What now? Potential equal to what? Q by C. What is the charge here developed? Q. Capacitance, already we know this capacitance is C. So Q by C is the potential developed at this point. See, what we can write? Change in potential across the capacitor is this Q by C minus this one G. So Q by C minus 0 na, Q by C for capacitor. See here, here potential V, here potential Q by C. I write here. What is the change in potential here? V minus Q by C by R. It is the current after time t. After t equal to infinite time, see here, it is the capacitor, resistor, see, cell or battery here connected. See here, here potential V, here capacitance, resistance or capacitance C. See here, after time t equal to infinity, t equal to infinite time, what happened now here? See, charge is completely means accumulated. So means here charge is completely charge is completely developed in this capacitor. See here plus q charge, here minus q charge. See plus q charge, here minus q charge. Again listen once here. See t equal to t time, small q charge developed here. Here minus small q means what is the charge now here? Q charge developed because of that here potential q by c. Here now after t equal to infinite time, what time now here? Plus q, capital Q here developed, here charge completely developed here. Yes, na? See that case here plus q, here minus q. What is the here potential na? Q by c. Q means capital Q by c. Actually q equal to what here? Q equal to c into v, capacitance into potential. See we can write here, we can take, it is the circuit, here potential V resistance or here potential is Q by C. It means here across capacitor. So I write here change in potential across capacitor is Q by C, means here Q means CV by C. What we can get here? CV only, means here this equal to what? V. I write here means I equal to V minus Q by C by R. Here V minus Q means what? Here we can write CV by C. C cancel by R. V minus V means 0, means I equal to 0. Means current is 0 when t equal to infinite time. So means whenever t reaches to infinite time, that case total charge is developed on the capacitor. What is the potential across the capacitor now? Q by C. Instead of small q we can write a capital Q. Capital Q means CV. So CV by C means CC cancel. What we get now here potential is developed is V. So V minus V across resistor same 0 potential. So 0 by something na, so 0 only, that's why current is 0. So means starting case t equal to 0 time, what is the current na? Maximum. T equal to t time, V minus Q by C by R time, R is the current. So finally now V I equal to 0 we get. So means what here, means after time going on, what now? Current will be decreases because of total charge is developed on the capacitors. Yes, na? This is the cases here. T equal to 0 time, what is the current? Maximum. T equal to t time, current is V minus Q by C by R. T equal to infinite time, what is the current na? 0. Again once written here, it is the capacitor resistor connected in battery. This we call it as RC circuit. T equal to 0 time, what is the charge developed? Means switch is closed immediately. What is the charge developed across the capacitor? 0. That's why charge is 0 for capacitor. So delta V here, delta V means across the capacitor Q by C. So Q means here what? 0. 0 by C means 0. So for capacitor, what is the potential across the capacitor? Not 0. Here 0. Here potential is what? V. What is the change in potential here? V minus 0. So means what we get? V minus 0 means V by R. Means I equal to what? V by R. V by R is maximum here. Next see here after time t time, what now? Here small q charge developed. Why now? Here electron taken and placed here. Here positive developed, here negative developed. One more electron. One more electron. Like this taken and positive. Now, what happened here? Q charge is developed. Capital Q equal to what? Small q. That case, what is the change in potential across the capacitor? Q by C. Q by C. See here potential here is V resistor. Here V, here Q by C. What here? V minus Q by C by R. That is the current. So means what is current here? Here maximum is there. Here somewhat decreases. Yes, na? See after t equal to infinite time, actually what is the charge developed here? Charge is completely developed, means fully charged. Fully charged means here plus q, here minus q. Here what is the potential here? Q by C. Q means capital Q. Capital Q means what here? CV. CV by C means what is the potential here developed now? V. Here 0. That case here C, here q by c means v we are getting. So means v minus q by c. Q is what here? CV, CC cancel, V minus V 0 means what is the current developed in this case now? 0. In this case we have two states of capacitor is the what now? First one I write here, this state I write again here, see here in this one we have two states of capacitor is there, two states of capacitor. What now? First one, see, it is the capacitor, it is resistor, it is connected to cell. See, current is flowing in this way. Here t equal to 0 time, what is the means? Initially means after switch is closed or switch on, so means initially t equal to 0 time, what is the change in potential now here across the capacitor q by c that equal to 0 for capacitor. For capacitor, this case, this circuit is act as, see it, the circuit is act as short circuited capacitor, short circuited capacitor. Why? Because here there is no potential difference is there here or resistance. Here potential is V, here 0, here also 0, so means across means, so means across the capacitor potential is same. Potential is same means it will be act like a wire connector. So that's why in this case what we can say now here, short circuited capacitor. What is the current now? I equal to V by R, it is the maximum current. It is the max. Whenever short circuited capacitor case is there, that case what is the current now here? Maximum current. Why we can say short circuited now? Here potential difference, here 0, here 0, so means there is no change in potential. Change in potential is there, it will be working. So here change in potential is not there, so means here it will be short circuited. We call it as short circuited capacitor. It will be just like wire connection only, it will be act. So that is the first case, case 1. So case 1 is what now here? T equal to 0 time, capacitor can be act as short circuited capacitor. Second case, t equal to infinite time. See here t equal to infinite time, I write here, see t equal to infinite time, charge is fully developed here. See in this case here, see here potential is V, resistance R, here what now here q by c is means means charge what here developed plus, here minus, here plus q, here minus q, means q equal to what here? CV. What is the charge developed? Totally developed means total charge is developed in the capacitors. What is the total charge? Capital Q equal to CV. So means t equal to t time, sorry infinite time. What now here? See, it will be like it will appear. See why it will appear now here? See, it is the resistor, it is connected to cell. See here, it here resistance is R, potential as V here. What is the here potential now? Charge is Q developed means what is Q? Capital Q means here I write here Q by C. That meaning Q means what here? CV by C. C cancel, what here? Potential V, here V. So potential V now what happen now here? It will be open circuit. Same potential now here. So means potential is 0 here. So that case delta V equal to V minus Q by C, that equal to V minus CV by C. C cancel. So 0 means I equal to what? Delta V by R. So delta V by R means 0 by R. So that is current is 0. That case it can be act as open circuit, open circuit capacitor. We have two cases is there. It is case 2, what not? T equal to infinite time, t equal to infinite time, t equal to 0 time, it will be act as short circuited capacitor. T equal to infinite time, it will act as open circuit capacitor. Why we can say open circuit capacitor na? Here total charge is developed plus Q, because of that here potential is V, here potential is V, so means V minus V 0. What is the current passes to this one now? 0. 0 means here circuit is open, no current is passes. So no current passes means circuit is open. Open means this is the case. So that case is, we can say t equal to infinite time, capacitor will be act as open circuit capacitor. Here t equal to 0 time, it will be short circuited capacitor. Short circuited capacitor means it will be act as wire only, connection only here, but no potential difference is there. That's why it will be, we can say that just a connector. Means for example, see, wire is there, no device is there, here current, potential difference same in wire. So like that here no potential difference here. Because of that, capacitor can be act as short circuited, that means not open, it will be like connection only, it will be like wire only act. So that is the first case. Second case, same potential, here potential developed is V, here potential V, so means V minus V 0, 0 means no potential change here. So that's why it is V short open circuit capacitor, it will be open. So means cut, that will be means circuit is break. So this case we can say t equal to infinite set, we can say that open circuit capacitor, t equal to 0 time, we can say that short circuited capacitor. Yes na? See, this is the circuits with resistor and capacitor. We can do problems now, then we know. See, we can do one by one problems here. For example, see, first problem, it is the circuit, resistor is there, here capacitor and resistor is there. Here see, it is connected to cell, it is the cell. Here what we want to do now, here see, find the current, find the current in each case. Each case means t equal to 0 time and t equal to infinite time. So both cases we find the current. See, here t equal to infinite time, we can say that steady state. Steady state, steady state capacitor is act as open circuit. This case we can say that steady state, t equal to infinite time, we can say that steady state. This case it will be act as open circuit capacitor. See, we can find out t equal to 0 time what is the current, t equal to 0 infinite time what is the current, that we want to find out. See, here it is resistance is R1, its resistance is R2. See, here I current passes, what now, here divided I1, here I2, that I1 I2 we can find out. For that, see, here first one, t equal to 0 time, what is the this one now, here in this case capacitor is act as short circuited capacitor. Short circuited capacitor means it's like a wire only. So means here it is the resistor, here capacitor will be act as like wire, so that one remove and capacitor means resistor is there. Here see, it is the circuit. Yes na? See, it is the circuit, means here plus, here minus, current is flowing this direction. So here is I1, here I2. So here again combine and coming out I. So this case what here, R1 R2 are parallel. Parallel means we can find the R equivalents. So what R equivalent here, R1 into R2 by R1 plus R2. Why? Because here current is divided, potential same here. So this case R equivalent equal to actually 1 by R equivalent equal to 1 by R1 plus 1 by R2. So that we can write R1 R2 by R1 plus R2. What is the current now here? I equal to V by R. So means R means here R equivalent. So it is the current finding when the t equal to 0 time, the capacitor will be act as short circuited capacitor. In this case, this capacitor is act as short circuited capacitor. That case, what is the current now here? V by R equivalent. What is the current in I1 now, first resistor now, here V by R1. What is the current in I2 now? V by R2. It is the formula for finding I1 current, I2 current and the total current. Now what here, I current is divided I1 I2. What is I1 na? V by R1, V by R1, I2 na? V by R2. It is the t equal to 0 time, it will be act as, capacitor will be act as short circuit capacitor. That case we can remove capacitor, just it will be like acting wire, connection only. Yes na? See, second case, t equal to infinite time means in steady state. Steady state, see here, second case, case 2, t equal to infinite time, we can say that it is steady state. In steady state, what is the current, that and all we can write. In steady state, capacitor is act as here, capacitor short circuited capacitor. Short circuited capacitor means it will be like connection only, wire acting. Here now, t equal to infinite time, capacitor is act as open circuit capacitor. Open circuit capacitor means, see here, it is the connection. Here capacitor is there, sorry, it is resistor. Here one more means resistor is there with capacitor, it is the circuit. Here see, it is positive, it is negative, it is the circuit. See here, current is glowing moving here, so this is the direction of current. Here positive, here negative. See here, current is flowing here in this way I. Here now open circuit. Open circuit means, so no current is passes to this one. This one is not valid, so means R2 is not working, only R1 working. Why? Because so capacitor is act as open circuit capacitor. Open circuit capacitor. This case, what is the current now? I equal to V by R1. It is the current when t equal to infinite time. T equal to infinite time. Yes, na? See once here, t equal to 0 time, capacitor is act as short circuited capacitor. Because of, we can remove this one, it will be like wire only. So R2, R1 is there. See, it is R1. In this case, current is now I, here divided I1, I2. Why? Because these two are parallel. So parallel case now I divided potential same. So that's why, what is the R equivalent now? 1 by R equivalent equal to 1 by R1 plus 1 by R2. So R equivalent equal to what? We can write R1 into R2 by R1 plus R2. I, what is the current now? Maximum current here, V by R equivalent. So from that I1 we can find out. I1 means here potential is V, resistance is R2, V by R1. For this I2 now, V by, here we can take, sorry, here I2, here we can take 1. So I1 by, I1 means V by R1, I2 means V by R2. It is the current. Yes, na? See, t equal to infinite time, steady state. Steady state means open circuit capacitor, means circuit is open, means capacitor is open case. So open case na, here no current passes, only here current passes. So we want to find out only this one, it will only working. So means here y equal to what? V by R1. Yes, na? It is the problem. Next, see here, one more problem. Here capacitor is there. Here see, one more capacitor, means resistor is there. It is the connection, it is connected to cell. It is the connection, minus plus, current is flowing in this direction. Here V potential, here 0. So means here V potential. See here, current is I, it will close. Here what now? Here we can divide I1, it is I2 here. So again combine here, coming out I. Yes, na? It is the circuit. See this case, what we can do now? Find the current in each case. T equal to 0 time, t equal to infinite time. Infinite time na steady state. In this state, we can find the current and also find the charge on capacitor. Also find the charge on capacitor. I write here third one. Find charge on, find charge on capacitor at t equal to infinite time. T equal to infinite means steady state. Steady state, that we want to find out. See here, first one, here see, 6 ohms resistor, here 2 ohm resistor. See, this is the circuit. This capacitance is 2 microfarads. This is the circuit actually. Here 2 ohm, 6 ohm and parallel. This resultant na, here this and this are parallel. See this case, find the current in each case. T equal to 0 time 1, second case t equal to 0 infinite time steady state, that is. Third one is find charge on capacitor at t equal to infinite steady state. We want to find out what is the charge on capacitor. See, for that what we can do now, first one, see current is moving this direction. See here I current, what happened here, divided I1 I2. See again, combine here, come out I. So this case, first one, t equal to 0 case, t equal to 0 case, this capacitor is act as short circuited capacitor, short circuited capacitor. We know this one. Why now? T equal to 0 time, charge developed is here 0, here also 0. So what is the potential difference now here? 0. That's why it will be act as like wire. So that's why we can say that it is short circuited capacitor. Short circuited capacitor means it will be like wire connection only. So that case, what is the circuit now? It is the circuit 2 ohm, it is 6 ohm, it is the connection. Yes na, see, it is minus, it is plus. See here, it is plus, it is minus. Here see, what is the potential now here? 12 volt potential, 12 volt potential. This case, what we can do now here, what is the current we find out? So for that, what these two are in parallel case, what is the R equivalent? So R equivalent equal to what? R1 into R2 by R1 plus R2. What is R1 here? 2. 2 into 6 by 2 plus 6. What we get? 2 into 6 by 2 plus 6 means 8. 2 ones, 2 fours, 2 threes, 2 twos. Means what here? 3 by 2 resistance na ohm, 3 by 2 ohm. What is the R equivalent na? 3 by 2 ohm. We want here, what is the current I? What is I1? What is I2? That we want. See here, I1 na here, first I we can find out. What is the current na here? See, current passes through the circuit na here. I equal to V by R equivalent. V is what here? 12 volt. Already gave 12 volt. 12 by R equivalent is what here? 3 by 2. See, I write here 3 by 2. Yes na, see here, R equivalent means 1.5 na, it will changes to numerator. So means 12 by 3 into 2, 3 ones, 3 fours. What na here? What is the current na here? 8 amperes of current is passes through the circuit. 8 amperes of current. See once here, t equal to 0 time, it is short circuited, capacitor is short circuited. Short circuited means here just connection of wire, connecting wire, like it will act as, see, t equal to 0 time. That case, it will remove just wire. We can write here 2 ohms, 6 ohms. These two are parallel. Parallel means R equivalence is what here? R1 R2 by R1 plus R2. We can get 3 by 2 ohm. What is the resistance na? 3 by 2. What is the current here? I equal to V by R equivalent. V is what here? 12 volt. Here resistance is 3 by 2. So what we get? 8 amperes of current. But here 8 amperes of current is there. While entering here, it will divided by, because parallel connection, I1 I2. But here potentially same. When parallel connection resistors are connected in parallel, current is divided, potentially same. Here also V, here also V. What is the potential here? 12 volt. Here also 12 volt, here also 12 volts. We want to find out now here I equal I1. So I1 means what here? V by R1. See, V by R1. V is what here? 12. What is R1? R1 is here 2 ohms. So 2 we can take now here, 2 ones, 2 6 means 6 amperes of current. I2 V by R2. So that is V is what? 12. R2 is what? 6 ohms. Yes na? 6 ohms we can take, 6 ones, 6 twos means 2 amperes current. What is the current across 2 ohms resistor na? 6 ampere. Across 6 ohm resistor na? 2 amperes. See again, 6 plus 2, we are getting current 8. Yes na? It is the first case. T equal to 0 time, capacitor is act at short circuited, means it will be act like wire connection, connecting wire only. So that's why 2 resistors here, 2 and 6 parallel. R equivalent we find out, I maximum we find out, I divided again, I1 we find out, I2 we can find out. Next is C equal to infinite time. T equal to infinite time. Second case, this case, it will be act as open circuit capacitor. Open circuit capacitor. Here, see, this we can state steady state. We can say that this one steady state. In steady state case, capacitor is open circuit capacitor. Open circuit capacitor means, now I draw the circuit here. It is 2 ohm resistor. It is will be like open. See here is there. See here 6 ohm. it is the connection. See, it is the connection here plus 12 volt. See here, in this case, what now here t equal to infinite time, it is we call it as steady state. In this case, this capacitor is act as open circuit capacitor. Open circuit capacitor means it will break, it will be open the circuit, means here, see here current I na, here I current, here no current passes, but already charge is fully developed here. What charge na here, capital Q charge is developed. Yes, see here, in this case, here 12 volt na, here also 12 volt. Why? Because potential is same here, here. Yes na, but current is moving this direction only. What is the current na here? I equal to V by R1 only. I equal to what? V by R1. What is V na here? 12 by R1 is 6, means 6 1 6 2, means 2 amperes of current only it will passes through this one. Here no current passes. Why? Because here open circuit. Yes na, this case, what is the charge on this capacitor? So charge equal to what formula? Charge equal to here C into V. C is what here, we know capacitance. What is the capacitance here? 2 microfarads. Here I write 2 microfarads into potential is what? 12 volt. But here 12 to the 24, means 24 microcoulombs. What is the charge developed in the capacitor at t equal to infinite time na? That is total fully charged. That fully charged case, what is the charge developed na? 24 microcoulombs. See here, t equal to infinite time, we can say that that is steady state. That case open circuit capacitor. In this case, these two will be parallel. Here potential V, here potential V, but capacitor is here what now? It is like open circuit. It is open, means here not allowing the current. Only current will be coming here, and this way it will be moving this here. This case it is not working, but capacitance is C. Charge is fully charged. Fully charged in that case only it will be open. So here potential is C, capacitance C, charge is Q. Here now, what we want to find out current. What is the current passes through this case? V by R1. V is what here? 12 volt. Why? Because parallel case both are same. What is the resistance now? R 6161, means what is the current here? 2 amperes. What is the charge developed on the capacitor at t equal to infinite time na? Q equal to CV. C means what here? 2 microfarads. It is 2 microfarads capacitance. So 2 microfarads. What is the potential here? 12. So means 12 ohms. So we can write 12 into 24, 24 microcoulombs. What is the charge developed in the capacitor at t equal to infinite time, in steady state na? 24 microcoulomb. What is the current passes now? Only this way current passing, this way not allowing, because of open circuit capacitor. Yes na, this is the problem. See one more, we can, this one, see we can change the circuit. Now see here, here see, here is the capacitor. It is the one more cell is there, it is connected. In this case, it is the circuit. See here, here 2 ohms, here 2 ohms resistor, here capacitance is 2 microfarads, 2 microfarads. Here what is the charge now? Here potential now 12 volt, potential is 12 volts. What is the current? What is the capacitance? What is the charge, sorry, what is the charge on the capacitor? So that we find out. See here, same, find current in each case. What is the t equal to 0 time? What is current here? So that and all we find out. See here, for this current is flowing this way, it is plus, it is minus. So coming this here, divided current I1, here I2. Yes na, see in this case, what na here na, t equal to 0 time, t equal to 0 time, we can write it will be act as short circuited capacitor. Short circuited capacitor, that means it is, see here, it will be just wire only. It is also, see here, it is the circuit, it is It is the circuit. Here see it is 12 volt, current is I, here divided I1, here divided I2, here 2 ohms, here 2 ohms. What we can do now, here first I equivalent means R equivalent we find out. R equivalent means R1 into R2 by R1 plus R2. Yes na? So R equivalent equal to what here? 2 into 2 by 2 plus 2, that means 4 by 4. So what now we get here? 1 ohm. So what is the current now? Here maximum current is what? V by R now. V by R. R equivalent. V means what here? 12 volt. R equivalent is 1. So means 12 amperes of current passes through the circuit. See I1 we want to find out. What is I1? V by R1. V means here what? 12. R1 is 2, so means 2 6 are 12, means 6 amperes of current. I2 we find out V by R2. V means what here? 12. 2 means 6 are means 6 amperes of current. Why? Because here 2 ohms, here also 2 ohms. 12 amperes current developed now. This develop 12 amperes current, here 6 amperes, here 6 amperes. Why? Because same resistors na. So that's why. See here t equal to infinite time. T equal to infinite time. T equal to infinite time. What is the find charge on capacitor? T equal to infinite time. So that case here see T equal to infinite time now. See for example it will be act as open circuit. See it is the resistor. It is here open. Here see it is working. Here see this one now. It is the circuit. See here 12 volt potential, here current is I. Yes na? Here is 2 ohm, here 2 ohm. See here before problem like that only, but values only change. Here what na? T equal to infinite time, it is open circuit. Open circuit means it is open, it is not allowing current, it is only allowing current. Here capacitance C what not 2 microfarads. Here charge is we want to find out. Here potential is here what not 12 volt, here also 12 volt, here also 12 volts. Why? Because both are parallel. Yes na? See here we want to find out what is the current here. I equal to what here? V by R1. So V is what here? 12. R1 is 2. So means what now here? 6 amperes of current. What is the charge now here? CV. C is what? 2 microfarads. V is 12. Here now 24 microcoulombs charge is developed. What is not 12 2 are 24. Here 12 volt now. So that's why 12 2 are 24. Volt we get now here 24 microcoulombs. What is the charge developed on the capacitor at t equal to infinite time? In steady state na 24 microcoulombs. 24 microcoulombs. See now next problem, it is the last problem. See once what now we have to do here. See once, for example here it is the circuit now. Here it is 6 ohm. Here capacitor is there. Here see, here capacitor, here 2 ohm resistor. It is the connection. See here it is the connection. It is the connection. See here it is 12 volt. Here current I, here divided I1, I2 here. It is 6 ohm. So again combine here, coming here I current only like this. Here process. So this is circuit. What we can do now here? Find current in each case. Here first case t equal to 0 time, t equal to infinite time, second one here, and third one find charge on capacitor at t equal to infinite time. T equal to infinite time means steady state. So that we want to do here. See once, in this case first one t equal to 0 time. T equal to 0 time means first case means it will be short circuited capacitor, short circuited capacitor means wherever capacitor is there, this will be like a short circuited capacitor. We know already t equal to 0 time means immediately after closing the circuit, immediately it will be act as short circuited, means it will be like wire only it will act. So I write, draw the diagram here. See, it will be wire like. So what we can get now here, it is wire, sorry, wire, here it is resistor. See here, so means here it will be like this now, here it will be, so means wire only now, so means here it is wire, so connection only, here it will be there. See here, in this case it is, 1 minute, it will be like this, 6 here, here 2 ohms, it is the circuit, yes na. See here it is 12 ohms, 12 volt. See here current passing here, coming out. See in this case it is like wire only, open means short circuited capacitor, that's why this one. See here, what is now here, here current is same, here same, here same. Why? Because this resultant is series with this one, yes na. So that's why it is what, short circuited capacitor na, it will be like wire only. So that case these two are series. In this case, what is the resultant equivalent na, 6 plus 2. In series case, r1 plus r2 means 8 ohms, 8 ohms. Here see, what is the current na, here v by r na, v by r, v is what here 12, r is what here 8 ohms. So means 4 2 jar, 4 3 jar, means 1.5 amperes of current. What is the current passes through the circuit now, here 1.5 amperes. But here potential is divided. Why? Because series case na, v1 here, v2 here, yes na. So what is v1 now, here v1 equal to what, I r. What is the current here, current is same, here 1.5, here 1.5, here 1.5, v equal to IR. What is I now, here 1.5, yes, amperes into this one. We can write here 1.5 into, what is the resistance, not 2, so means here 3 volt. Here v2 equal to now I r2, I means here 1.5, r2 means 6, 15 6 are 90 means 9 volt, means here what is now, here 9 volt potential, here is 3 volt potential, here also 3 volt potential it develops. Why? Because here these two are parallel case, that's why what is potential here, it is also same. So that's why we find out here v1 equal to 3 volt, v2 equal to 9 volt. What is the current now, here 1.5 amperes. Why? Because it is series connection, current is same. In this one, see here t equal to infinite time, what we find out now, what is the current in this case, t equal to infinite time now, here see circuit, infinite time is here, see here it is open circuit, it is open circuit, it is here connection is there, here see it is the circuit. See here it is 12 volt, here it will be current I, here 6 ohms, it is 2 ohms, it is capacitor and charge q is developed, and potential is what now, here we find out already. What is potential here, 3 volt, here 9 volt, here right, it is 9 volt potential, it is 3 volt, here also 3 volt. See here in this case, what now, here it is open, it is not working, it is na, this one series, yes na, series means what, here we know already current. What is the current now, I equal to v by r, that is we get already, these two are series na, so means 12 by 8, so means 4 3 jar, 4 2 jar, 1.5 amperes we get current also. What we want to find out now, here third one, find the charge on capacitor at t equal to infinite time. What is the charge? So for that charge formula now, see here, what is formula, C q equal to Cv. What is the C here? 2 microfarads in this one, sorry, here 2 microfarads. 2 microfarads now, here it is capacitance is 2 microfarads, potential is 3 volt. What now, here 2 into potential is what, here 3 volt, so means what, here 6 microcoulomb. What is the charge developed across the capacitor now? 6 microcoulombs of charge is developed in this case. See here, t equal to 0 time, it is short circuited capacitor. T equal to infinite time, it is open circuit capacitor. Open circuit capacitor. Open circuit now, it is break. Only it is the connection. Is current is moving this way. Yes, na? So this is the solution. Please see the videos, subscribe the channel, share to your friends and relatives. Thank you.